Hi, I am Aditya from grade 7, Shukriya High School. Today I will be talking about thermal inertia. Do snakes understand physics? Snakes are often spotted on concrete roads or houses in the night. This can be explained by thermal inertia. Concrete absorbs heat faster and retains it for longer compared to the other surroundings. Do you feel that in summers the house is cooler in the day, and when in the evening, if you go outside, it suddenly is colder outside? This is also thermal inertia. Thermal inertia, the property of the metal that expresses the degree of slowness with which the temperature reaches that of the environment. Thermal inertia can be computed as follows. I is equal to K rho C to the power of 1 by 2. I is equal to thermal inertia. K is equal to thermal conductivity. Rho is equal to material density. C is equal to specific heat capacity. To demonstrate this, we made a wooden box, a concrete slab as a roof, and measured the temperature at different points of the day. We found that at 4:30 in the evening, the temperature has a crossover point. When the sun sets, the concrete temperature doesn't change and slowly just drops, whereas the surrounding just dramatically drops. This makes the room warmer in the night. Have you observed that in cooler regions there are wooden houses and in hotter regions there are concrete houses? This is because the material used impacts the cooling or heating. This is our experimental model. This is a front panel which we placed here to simulate a closed room. Then we placed a slab of concrete to simulate a roof. Then we placed the measurement probes, one through a ventilation area in the main room and one on top of the concrete like this. After this, we then added a wooden false roof over here. We placed the concrete roof afterwards. We placed the front panel after this and then took the measurements to see the differences. After we used this wooden panel as a false roof, we switched to a POP panel and repeated the same procedure. And we took the temperature at different points of the day and across many days. With this, we used the slope and intercept concept of the rising and falling curves to determine the temperature at a certain point of the day. With this, we found that the thermal inertia of concrete is the highest, followed by POP and lastly wood. This is why wood is used in houses in the colder regions. Wood is a low thermal conductor, which means it does not allow heat to move through from the surface to the interior quickly. And in simpler words, if you heat the room, the heat does not escape from the room for a long time. Finally, this small concept of thermal inertia is vital when it comes to space missions, as if you land on an asteroid, the rover can, if using thermal inertia, you can determine whether the sample is a rock, a metal, or dust, or whether you want it or not.